Review video 16, Bridge Circuits, Part B. Noting that the point at the top has a potential of 10 volts, so that's right there. For each element in the grounded circuit shown, determine, as appropriate, the current through it and/or voltage across it and/or the charge on it for when the switch is open, and then we're going to do when the switch is closed. Let's go ahead and see what we can see here. If this is grounded, that means that it has a potential of 0 volts. And that means that this entire portion here and that portion and all of this have the same potential of 0 volts. At the top, we have a potential of 10 volts. This whole region right here is charged up to 10 volts. And then what else do we have? We have 2 sections of the circuit where the switch is open. So this portion is going to have a certain potential. And finally, this portion over here is going to have a certain potential, which we don't quite know yet, but hopefully we'll be able to figure all this out. Well, let's see what's happening here. I'm looking at this circuit and I'm seeing that there can be no charge flowing through it here at first, because we have an insulator there, we have a break there, we have an insulator there. So actually what happens here at the beginning is, because we don't have any current that's actually flowing, it doesn't take very long before this whole thing will have a potential of 10 volts. This whole region will be 10 volts. Now, here's the thing. If there's no current through the 4 ohm resistor, which there isn't, let's put that in. There's no current. If there's no current, then there can't be any potential difference across it. So this whole upper right portion of the circuit is charged up to a potential of 10 volts. Same thing happens down here. If there's no current that can go through this resistor here, that's supposed to be the same color blue as what we had before. This whole thing, the same potential, 0 volts. No current going through that 1 ohm resistor. If there's no current going through the resistors, then there's no voltage difference across them. Whoops. Volts. The voltage difference then across the 2 farad capacitor, it's 10 volts on one side, it's 0 on the other, so that's 10. Same thing with the 3 farad capacitor. The pressure difference is 10 volts. And how do we calculate the charge on the capacitor? Once more, the capacitance is Q over V, so that means Q is C times V. Q is C times V. That means we're going to take the capacitance, which is 2, times the voltage, which is 10, and so I'm thinking 20 coulombs there. For the 3 farad capacitor, then we're going to have 30 coulombs. So that's the deal when the switch is open. When it's closed, then we have a situation that I started to get into here at the beginning of this video, and that is that this portion will be charged up. That has a potential of 10 volts. This portion down here will have a potential of 0 volts. And then I started to color the middle portion different colors. Well, here there will be only one different color in that center section. When that switch is closed, all of this has to have the same electrical pressure. So this whole region right here has one value of voltage, which we don't know what it is quite yet, but we do know that this bottom blue part is 0 volts and the top part is 10. So let's see what we can do here. Well, there will be current flowing through here now, and it will snake to the right and then back to the left. The resistance is 5 ohms, and the pressure difference is 10 volts. So I think there will be 2 amps going through the 4 ohm resistor. There will be 2 amps going through the 1 ohm resistor. The pressure difference or the voltage drop across the 1 ohm resistor then will be I times R. So that's going to be 2 volts. I times R, 8 volts. There we go. The voltage has dropped by 8 going across the 4 ohm resistor. It was 10. You see up here where my finger is in the upper right. It was 10, and now, according to our table, it's dropped by 8, which means the voltage of this greenish region is 2 volts of electrical pressure. And that agrees with the number on the left that I'm pointing at right now, that the voltage drop across the 1 ohm resistor should be 2 volts, which it is. Now, we can see from the color coding that the voltage difference, or the pressure difference, or the voltage, you might say, a number of ways to say it, across the 3 farad capacitor is also going to be 2 volts. The voltage across the 3 farad capacitor is going to be 2 volts. The voltage across the 2 farad capacitor is the same as across the 4 ohm resistor, which is 8. So now, charge is capacitance times voltage. So 2 times 8, 16 coulombs. 3 times 2, 6 coulombs.